This video is going to explain how you take notes in your logbook for the Apsc 1299 course. But first, I'll just talk a little bit about why the logbook is important and also about the idea of permanence. So first of all, the reason why you're keeping a logbook for this course, obviously, is that you'll get grades for it. So this is the document that you'll be handing in to your lab instructor, and this will be marked. There's another reason to take really good notes, and that is your course instructor will allow you to bring your logbook into midterms and quizzes in class. So that means you can use your logbook as a reference during exams. So in this course, your logbook is really important. But in a more general way, engineers and scientists keep handwritten notes just as a matter of professionalism. It allows you to say exactly what you saw, exactly what you did, without having to rely on your memory. You'll have a record of everything you did. So professional engineers keep logbooks, and you will too, in this course. And this video is going to explain what we'd like to see in your logbook. So now let me talk about permanence for a moment. So logbooks are admissible in a court of law in certain situations because they're a permanent record of all of your work. So there's a couple of things we need you to do in order to make your logbook a permanent record. First of all, you should only be using a logbook that has glued in or stapled in pages. So not spiral bound and not loose leaf paper. We do require this in the lab, and that's just so that one page can't go missing without anybody realizing. So glued in or stapled in pages only. You should write in permanent ink only, so no pencil. If you make an error, cross it out with a single line, and then write the correction nearby. The idea here is that everything is still readable, both the correction and the original mistake. Likewise, never use whiteout, never scratch something out to the point where it can't be read. You don't want to obliterate any information from your logbook, so just a single line through anything you want to cross out. You should also never write things on scrap paper with the intention of then copying it neatly into your logbook. All of your work should go directly in the logbook immediately. You can put it on the back of a page and label it rough work if you want. And finally, messy is okay. You're allowed to have things X'd out and comments written in the corners. That's all totally okay. So now let's talk about what we want to see in your logbook for this course. So first of all, your logbook is going to look a little different than the lab notebooks you keep in other courses. So there will not be an objective section and a data section. Instead, you're going to be aiming to write down a real-time diary of what you did as you were doing it, including mistakes and things that didn't work out right on the first try. And you don't need to write down every little detail, but we do want you to try to preserve specifics rather than generalities. So to begin with, if you're starting a new experiment, it's a good idea to put down the lab title. And something else that we want you to do is we want you to put page numbers on all your pages. They can be at the top, like this, or at the bottom of the page. Another thing that would be useful to do is that we are going to, later on, be having you split your work up into 3 sections. So it might be a good idea to take a pencil and just split up the main body of the page into 3 sections like this. Now what you do next is you would read your lab manual and figure out what you're being asked to do right now. And then we want you to write down a task list. So that's not the entire experiment, it's just one or several tasks that you want to complete. So in my example here, I've just got one task. I want to build a few circuits and measure the voltage, the current, and see how bright the LED lights up. At this point, we're now going to make use of these 3 columns. So all your notes are going to take the form of an attempted solution, and then the results of that attempt, and then any notes that you think are important about what you just learned. You will also be wanting to write down timestamps. So specifically, we want you to write down the time when you start and finish something. So I'll start by writing down the time. However, if you're just starting work on a new day, it's also a good idea to put down the date. So at the beginning of a new day, write down the date and the time, and then you'll also record the time regularly as you're working. Now our task was to build various circuits and take some measurements. So the first attempted solution is just my first circuit. So what I would write down is build my first circuit, and I put a circuit diagram. So this is just a really quick, compact explanation of what I'm trying to do right now. So you would build the circuit, and then you'd evaluate how it turned out. So that'll go in your results section. So the result was that the LED in this circuit turned on, that it was bright, and then if you need to take some measurements, you'd want to write down your data as well. Finally, if there's any notes, anything that you think is important to record, then you do that in your notes column. And one thing that is actually quite important to record is if you need to do a calculation write it out in detail to show exactly how you got those numbers. So if you want the current, show a calculation of the current. If you want the power, you show a calculation of the power. The reason why this is important is that if you came back to this years from now, you wouldn't have to wonder, how did I get that number? You could just read it. Also, if you're bringing your logbook into a midterm exam and one of the questions says do this and it's something that you did in the lab, you can just flip back to that lab and look up your calculation, and that gives you a really good head start on finishing the exam question. So I do recommend that when you need to do a calculation, you do one sample calculation in detail in your notes. So that's our first attempted solution, and we're basically done with this circuit. So you should always write down the time when you begin and when you end. And if you're continuing on with something else, then that second timestamp can also mark the beginning of your next task. So the next task would be my second circuit. So again, I write down the attempted solution, then I would begin building it. And when I'm done, I would test it. So I'd write down my results. LED turns on again, it's brighter, and I write down my measurements again. And again, I recommend that if you've got some calculations, you do them in detail in your logbook. So now I'm going to show you this again with a slightly more complicated set of tasks. So now let's say that you're continuing on with your experiment on a fresh page, same day. So again, put the page number on and draw some pencil lines to split the page into 3. And again, the first thing you want to do is write down a task list. And in this case, it's going to be a slightly more involved set of tasks, so I'm going to write a few of them down. So the tasks are going to be that we're going to build a circuit consisting of a button, an LED, and a microchip. We're also going to create an MP-Lab project using some supplied code from the Moodle site. And then finally, we're going to add our own code to that supplied code to create what's called a soft toggle switch for the LED. And that's a switch that would turn the LED on when you push the button once, and turn it off when you push the button the second time. So again, I'll put down the headings, where we'll have an attempted solution, the results, and then any notes that we think are important. And as before, we write down a timestamp when we start, and because I'm still continuing on the same day, I don't need to write down the date. So our first task is to build a circuit. So we start out very similarly to how we did before. We'd say we built this circuit, and we draw our circuit diagram. Now the results at that point aren't very interesting because this circuit won't do anything until after we've completed the code, so we just write that down. It's also a good idea, as always, to write anything you think is important in your notes section. So now that the circuit is built, you put down another timestamp saying you're finished, and because we're continuing working, we can then use that as the timestamp that starts our second task. So I'm going to scroll down just a little bit here. The second task is that the student builds a project using the supplied code. And the result is that the project built and there weren't any errors, which is good. If there had been errors, they'd want to write down the error codes here, and then they'd have another line here where they tried to fix whatever problems they had in their project. And there's nothing here that the student thinks is important to write down notes on, so we can continue to the next task. Again, write down the time when you start and finish something, and you can use that timestamp as the beginning timestamp for the next attempted solution also. And I'm going to scroll down a little bit again. The next attempted solution is that the student actually wants to start writing their code. So they have to add code to the supplied code, this softtoggle.c file. And they write down here what code they intend to add. This is just pseudocode, so you don't have to write down everything in detail, but you should capture the logic of what you're going to put in your code. Also note that they have an error here, something that they wanted to fix. So they crossed out what they had with a single line so it could still be read, and just wrote the correction nearby. So this is the code that the student wanted to add to their project, and then they test it, and they find that it's not working the way they intended. So this is pretty normal when you're working on projects, is that you won't get it right on the first try. That's totally okay, you just write down what you actually saw. So in general, it's not enough to say something's working or not working. You say what you saw that led you to conclude that it was working or not working. So the student here outlines that the LED turns on when the button gets pressed, but then it turns off when the button is released. And that's not what the soft toggle is supposed to do. So they would think about it and maybe talk to people, and then make notes if they thought it was appropriate about what they planned to do next. So in this case, they say they asked a friend who said that they're only supposed to be programming the button to do something when the button gets pushed, not when the button gets released. So that'll be the next attempted solution. Put down a timestamp saying you finished the previous task and you're starting a new one, and write down the next solution, which is to change the code to this form. Then the student would test it and write down their results. And the results are that it's working properly this time. But remember, it's not enough to say something works or doesn't work. Write down the specifics that led you to conclude that it's working now. So in this case, the LED turns on when the button's pressed once, and it stays on until the button gets pressed a second time. And that's the correct behavior. But the student writes down some other notes. They talk to the lab instructor who said there's actually a better way to do that. And so, again, write down the time. And in this case, the student says, you know what, I'm going to give up for today. I'll try that idea tomorrow. And then they would just leave off here. The next day, they can then start again. And you'll notice that they put down the date when they're starting on a new day and the timestamp, and then they would continue on the way you've learned, writing down an attempted solution, the results of that, and any notes that they think are important. And finally, the last thing you need to learn to do is how to paste in things like graphs or oscilloscope traces. So obviously, if you have a graph that you can print out, you just trim it to size and tape or glue it into your logbook. With oscilloscope traces, back in the old days, what you would need to do is actually graph it by hand on graph paper to scale, with labeled axes and a title. Luckily, however, these days most oscilloscopes will let you save the image on the screen to a data stick, and then you can print it out and paste it in. It's also acceptable to photograph the screen in high enough resolution that everything can be read, and then print that out and paste it into your book. One thing to note with anything that you paste into your book, however, is you should put a title on it. So for example, the student put Part A as their title. That's not good enough. The ideal is that you want to be able to look at this years from now and tell just from the title what this image was. So for example, a title like this is much better. It explains exactly what's on the screen.